to biostatistics made easy. Today's lesson is on understanding and summarizing data. Let's do a brief recap on last week's lecture. Last week we covered the types of variables, continuous, ordinal, and nominal, differences between population versus sample, and types of investigation such as observational, experimental. So the outline for today's lecture is why we summarize data, how do we summarize data, distribution curves, normal distribution, and probability. So why do people even summarize data? Well, statistics is all about data. We summarize data to make it easier to understand and see the big picture of the data you have collected at a glance. It is also a way to communicate the salient points of this data set to others without having to recite the whole string of numbers. It also helps with prediction. Believe it or not, we do this every day. Let me ask you a quick question. How much do you spend on a meal in school? Let's hear some of your seniors' answers.
So guys, how much do y'all spend in school for one meal?
I spend $4 on a meal in school.
Hello, I spend on average $2.30 for my meals at Science Canteen.
I think I spend $0. Because I pack lunch, not think I spend $0.
About, roughly, on average. Do these words come out? If so, you are already summarizing data in your head. It's actually really easy peasy. The fact that you can do it unconsciously without us teaching you anything is an indication that all of you will get this. Let us use the same example. When I ask you how much do you spend on a meal in school, no one will say on Monday I spent $5.20, Tuesday $4.50, Wednesday $5.10, Thursday $1.60, Friday $7.60. You just give an average and a range. For example, about $4 plus minus 1, or even give a range of $4 to $5. If I ask you a further question, how much do you think you will spend on a meal tomorrow? You may say about $4. This just proves my point. You can and already are summarizing data. Summarizing data is about communication. Summarizing data helps in prediction. Moving on, how do we summarize quantitative data? Let me give you a definition that I'll break down later. A data distribution can be summarized by giving a measure of its location and its dispersion. This basically means that we describe a set of data using two things. One, location, and two, dispersion. Using the same example as the above, we summarized our data like this. I spent about $4 plus minus 1. $4 represents the mean, a type of location. Plus minus 1 is like a standard deviation, which is a type of dispersion. Let us move on to different types of location. So the first type of location I'll go through is mean. Mean is the same as average and is calculated by taking the total sum of the different items divided by the total number of items. Median is the middle value of a ranked data set. It's not suitable for nominal scales. It is useful for skewed distribution curves or when some values in a distribution are unknown. Mode is the most frequently occurring value. In this string of numbers on the slide, what is the most frequently occurring number? Next, I'll move on to measuring quantitative data with dispersion. Dispersion basically measures how far the data deviate from the calculated mean. Using the same example as above, I spent about $4 plus minus 1. So this plus minus 1 is similar to standard deviation. Standard deviation is the square root of variance. Variance is the deviation from mean, which is squared, then summed, then averaged. So standard deviation is also suitable for continuous variables. So now we are talking about distribution curves. Well, mean, mode, and median, as well as standard deviation, just gives you a numerical representation of summarizing data. We can also chart and plot the data for a visual representation. So let us first visit some terminologies that describe distribution curves. So the first one is unimodal, bimodal, and multimodal. So these different terms describe the number of peaks in a curve. So for unimodal, that is when you have one peak. Bimodal, two peaks. Multimodal, more than two peaks. You can also describe a distribution curve by describing its symmetry. So the first one is symmetric. Symmetric curves, such as the normal distribution curves, occur when the mean equals to median equals to mode. A skewed curve can be positively skewed or negatively skewed. Positively skewed curves have a long right tail, as seen in the diagram, and usually its mean is more than its mode. For negatively skewed curves, it has a long left tail and usually its mean is less than its mode. Another term to describe distribution curves is range. Range is the difference between the smallest and largest values in distribution. Certain terms like interquartile range describe the middle 50%, semi-interquartile range describing half of the interquartile range, and a 10 to 90 percentile range, P90 to P10. Take a look at this diagram. On to normal distribution. So as you mentioned earlier, normal distribution curves combine unimodal and symmetric properties. Normal distribution curves are also continuous. And as a symmetric curve is described, its mean equals median and it's equal to its mode. The area under its curve is also 1. At both ends of the curve, they tend to 0 as they move away from the mean. A normal distribution curve is commonly used because biological characteristics conform to it. Let me give you an example. Drawing a series of samples from a population and calculate the mean of observation in each sample, we'll find that these means generally conform to the normal distribution, even if the observations from which they are obtained do not. Next, we'll talk about probability. So probability is all about chances. Let me give you another example. What's the chance that Michael's average spending, for example $8, is significantly different from that of the class? So usually in probability testing, we have to come up with a null hypothesis and an alternative hypothesis. So the null hypothesis states that there is no significant difference between Michael's average spending and that of the class. The alternative hypothesis states that there is a significant difference between Michael's average spending and that of the class. As we want to find out if Michael's spending is significantly different, we need to conduct t-tests to determine a p-value. This will be covered next week. If the p-value is less than 0.05, we statistically agree that there is a significant difference and hence reject the null hypothesis. Sounds a bit confusing? Hang on! So what is the p-value? The p-value is the probability of obtaining the result equal to or more extreme than what was actually observed when the null hypothesis is true. So take a look at the diagram at the top right hand corner. So this shows a normal distribution. So the shaded area on the curve represents the probability of having a value of z or more extreme than z. The significance level of 0.05 is commonly agreed upon among investigators as like the cutoff. When we say significantly different, there is a probability of more than 5% that variable x should lie outside the 2 standard deviations from the mean. If variable x has no significant difference, it has a 95% chance of lying within the 2 standard deviations of the mean and the normal distribution curve. So what happens when we accept the null hypothesis? It just means that we conclude that there is no significant difference. That means that the value that we are trying to test lies within this shaded area. When we reject the null hypothesis, we are saying that there is a significant difference between Michael's spending and that of the class's average. This means that microspending lies somewhere within the shaded areas on the extreme ends of the curve that we see on this diagram. So going back to this curve, you see that there's 95%, 68%, 99.7%. What this means that there's a chance that his spending is within one standard deviation away from the mean is 98%. The chance that his spending is within two standard deviations from the mean is 95%. The chance that his spending is within three standard deviations is 99.7%. So that is the end of our lesson today. So in summary, what did we cover? We covered why we summarize data, how we summarize data, distribution curves, normal distribution, and probability. So that's the end of our lecture. Thank you.